Okay, here we go. This is PAT from 2008, released PAT. First question says this item was not released. Don't know what they mean by that, but let's just do this question. Anyway, so it says we've got the following expressions are examples of powers. Here they are. 1, 2, 3, and 4. We have different powers here. And it says to list them listed in order of increasing value, the expressions numbered above are. So increasing value, so we're going from small to big. That's what increasing value means. So let's just evaluate these. So we have something we might be less familiar with, negative exponents. I'm just going to explain quickly what a negative exponent means. Okay. So if I have something like 2 to the negative 2, what that means, what we do is with a negative exponent, it means we take this number here, the base, and we put it to the exponent, but on the bottom of a fraction where the numerator is 1. So what I'm saying, I'm going to take this 2 and I'm going to make it squared, and on top I'm going to put my 1. So I would have 1 over 2 squared. So what is 2 squared? It's 4. So that would equal to 1 over 4. Okay, I'll kind of explain where that rule comes from quickly so you'd sort of see that it makes sense to you. Okay, let's say I had something like 2 to the 0. What is 2 to the 0? We know that that's 1, right? Okay, so I have 2 to the 0. If I had 2 to the 0 over 2 squared, if we use our exponent rule for dividing, this is 2 to the 0 divided by 2 squared, we would say 2 to the power of 0 minus 2, right? We subtract exponents. And what's 0 minus 2? It's 2 to the negative 2. Okay, so we would express something like that as 2 to the negative 2. Now remember, we said anything to the power of 0 is 1, so this is 1. And on the bottom I have 2 squared, which we already evaluated as 4. So when I see something like this, 2 to the negative 2, it just means we're going to write that without that negative in the exponent, but that negative in the exponent just means we're going to take this and put it on the bottom of a fraction where the top is a numerator of 1. Okay, I think there's another one here, so we'll practice that again. Okay, so our first one, number 1, we figured out already is equal to 1/4. Next one, we have negative 2 squared. So my negative is on the outside of those brackets, right? So we're just squaring the 2. We're leaving that negative sign alone. So I'm just going to write my negative sign down, and 2 squared is 4, and that's my answer for that one. Okay, so number 2, the value is negative 4. Okay, let's do the next one. Here this time, my power is operating on these brackets, right? So it's the whole thing is squared. So it's like negative 2 times negative 2. Also, if the exponent is even, we know that we're going to have a positive value. So this is 2 squared is 4, and I know my value is going to be positive. Okay, again, you can just expand that if you want to. Negative 2 times negative 2 will give you positive 4. Okay, so this one is 4, but positive 4. And then here we've got negative 2 to the negative 2. Okay, so remember this exponent here is operating on this number 2. Okay, so it has nothing to do with this negative. We're going to just leave that negative alone. And as we just learned, when we have a negative exponent, we write that as 1 over. So let's just start by, let's leave our negative sign alone. Okay, let's just leave it there. And, oh, that was thunder. And now I'm going to write this part here as we just learned. So I'm going to have 1 on the top and over 2 squared. So we get negative 1 over 2 squared, which is 4. So we have negative 1/4. So this one has a value of negative 1 over 4. Okay, So we've answered those now. Which is my smallest number? It's the one that is most negative. So on a number line, this would be farthest to the left because it's more negative than this. 1/4 is a small number. It's just a little bit less than 0. -4 is much less than 0. Okay, so our first one is going to be that one, number 2. So we have another negative number, which was 1/4. So that's the next one in if we're following our number line, that's the next biggest number. Now we're into the positive values. So between 1/4 and 4, 1/4 is smaller, so it's less positive. So it's the next one in the row, and 4 is the largest positive number. So that's the biggest. It's in increasing. Oh, it's increasing in value. If we think about our number line, right? Those would all be lined up on the number line here. Number 4, somewhere here, 1/4, then positive 1/4, and then positive 4 this way, right? Okay, there we go. That's question number 1. That only took me 6 minutes to explain. But you will be able to do that much quicker on the test because you don't have to explain it. You've just got to write it and get your answers in, put your answers in. Okay, oh, I see. So that was numeric response. I see. They meant item number 1, multiple choice, was not released. Okay, so maybe they used it again on the following year. Same with 2 and 3, multiple choice. Okay, so we're going to question 4. What is the value of x in the equation? Okay, so we're looking at exponent rules. So let's just rewrite this. 2a to the -3 times 6a to something, okay, to some exponent. We don't know. Here they put an x on the test you guys did today. They just used like a dark square. Doesn't really matter what it is. It's something that we don't know, right? Is equal to 12a to the 15. So we can see here they multiplied 2 times 6 to get 12. And then we're multiplying. The next thing we're going to do is multiply a to the -3 times a to something we don't know. So remember, when we multiply numbers, we add the exponents. So for example, if I had a squared times a cubed, I would add those, right? A would be 2 plus 3, and we would have a to the 5. So here up above in this question, we're saying I've got, make a space here to write this down, I've got a to the -3, because we multiply our numbers that we know, and then we can multiply these together, right? Our unknowns, our variables, like our letter A, okay? So I've got a to the -3 times a to the something we don't know. Will have to result in this here, a to the 15. So remember, when we multiply, we add exponents. So this is like saying -3 plus something, my x, this unknown, is equal to 15, right? We're adding these exponents to get this. So what are we missing? So we would have to add some, whatever that would get us to 15. Now you could do this a couple ways. If you just kind of good with mental math, you realize you need 3 more to get up to 0 and another 15. So we would have to add 18 to get us to positive 15, right? So that means our x is 18, that missing number, that missing exponent. You could also just do it a little more literal, like the way we solve equations. So if I have here my -3 and this x have to add together to give me 15, then you could just literally write that. I'm just doing my exponents, right? Following my rules for exponents. When I multiply these two numbers with the same base, we add the exponents. So I'm just going to add them. -3 and x is equal to 15. Now we just can treat it like an equation solving, right? So add 3 to both sides. Cancels out. And 15 plus 3 is 18. Okay, so if you're not as strong on that mental math, you can just follow this procedure and solve equations like we normally do. Okay, so there we go. D is 18. So if you've never seen a question like this before, like it's stuff that we've learned, but there's kind of a couple levels going on here, right? So might look a little confusing at first, but once you try it, you'll get the idea, and hopefully you'll be able to answer a similar question if you see one. Okay, so let's carry on. Question number 5. All right, so the estimated mass of one of the smallest living organisms is 1 times 10 to the negative 16 grams. How many of these organisms are needed to have a total mass of 1 gram? Okay, so let's see, I'll try to make this a little bit easier. If I say I have 1 times 10 to the negative 16, this is representing the weight of one of these little organisms, maybe a little bacteria. Okay, so that's the weight of one of those. 1.0, same as 1. 1 times anything is just 1. So why don't we just kind of make this easier and think of this? We're saying 10 to the 16, negative 16. That's the weight of this thing, right? Okay. So from what we just said a second ago, we can say that this is the same as 1 over 10 to the 16. Okay, so that's the weight of this thing. That's the weight. It's that many grams. That's how much it weighs. It's very small. That would be 1 over, right? If we had 1 over 10, that's like 1/10. If I had 1 over 100 and 100th, that's really small. This is 1 over 10 to the 16. I don't even know what you call it. Million, gazillion, billion, something like that. So it says, how many of these organisms will we need to have a total mass of 1 gram? Well, you would take the weight of this organism, this 1 over 10 to the 16, and multiply it by the number of organisms you need to get 1 gram, to get 1, right? To get 1. So what would I multiply here to get 1? Well, I want to think about this. Now we have this like a fraction. I want to cancel this out. So I'm just going to multiply this on top by the exact opposite thing, right? So 10 to the 16, which I could also write as 10 to the 1, right? If I multiply these across the top, I'll have 10 to the 16 on the top and 10 to the 16 on the bottom. And that's just going to give us 1, right? Anything divided by itself is 1. So our missing number of organisms was 10 to the 16. Okay, so, and here they wrote as 1 times 10 to the 16. So that's how many organisms it would take to get 1 gram. So let's maybe just try this again. Hopefully that made sense. Maybe just do another example just to practice. Let's say if I tell you I have something that weighs 1.0 times 10 to the negative 5 grams, and I say, how many organisms would I need to get to equal, should I say, well, let's just do 1 for now. Let's keep it simple, to equal 1 gram. Okay, so I know I've got 1 times 10 to the 5th, or now I could write it as a fraction. That was one way. Okay, here I just chose to write it as a fraction to see if seeing it that way would help. The other way I could just do is like this. I'm just going to write it again. I'm just going to leave out this 1 for now. Okay, so because I know 1 times anything is the same thing. So I'm just going to write this as 10 to the 5th. If I multiply that by something, I should get 1. Now remember we said anything to the power of 0 is 1. Okay, so what if I was looking to get 10 to the power of 0? So 10 to the power of 0 would be 1, right? 2 to the power of 0 is 1. Anything to the power of 0 is 1. So in this case, how could I get 10 to the power of 0 so I get this to be equal to a 1? I can remember if I put another one of these numbers here, 10, and if I make this this exponent the same value as this, but positive. In this case, we know we're going to add exponents, right? So if I add my exponents, -5 plus 5, that gives me 0. So that would be like saying I get 10 to the 0, right? Which is 1. Okay, so that gave us our 1 gram in that case. So, kind of two ways you could look at doing this. And that was just a random example I was trying to give you, but let's just actually do this question over again as though as they asked it. So if they were asking for, excuse me, we said we had one organism weighs that much. So I can write that as 10 to the -16. If I multiply it by 10 to something to get 10 to the 0, so we get 1, it would be 16, right? So the 10 to the 16 is the number of organisms, and they write that kind of like in sort of like a scientific notation. So 1 times 10 to the 16 would be the right answer. So between these two methods, method number 1, method number 2, do the one that you would like the best. And then what if you were asked something like that, except instead of 1 gram, they said, I don't know, 2. Let's say if they said, just same as before, we have 1.0 times 10 to the -16 is the weight. And they say that how many organisms would we need to get 2 grams? So we'd say, going to multiply its weight times the number of organisms that we need to get 2, right? To get 2 grams. So I would do basically the same thing, but I would just multiply by 2, right? So if I can take this and just rewrite this as 10 to the -16, to get 1, I would just multiply by that opposite exponent, by that number that's basically the opposite, right? 10 to the 16, because I know that's going to give me 10 to the 0, and 10 to the 0 is 1. So since that equals 1, I would just take that whole thing and multiply it by 2, right? So I would say like I've got, this is, let me just scroll up here. So this is the weight. This is how many grams. It's 10 to the -16 grams, a very, very small amount of weight. And then 10 to the 16, which is a huge number. It's like 1 gazillion billion. That's how many of those little bacteria we would need to get 1 gram. Well, I'm just going to double that by 2 to get 2. So my answer in that case would be 2 times 10 to the 16 instead of 1 times 10 to the 16 as we had in our answer above. Okay, hopefully that helps. If you get confused or you have any questions, please let me know. All right, let's move on. Okay, we don't need to see that. Okay, number 6. And we're almost at 20 minutes here. Actually, I'm going to keep recording because I can only upload a certain number of videos per night, but I can upload videos that are like, I don't know, up to like 24 hours long or something. So I'm going to go for longer videos on these ones. All right, the perimeter of a triangle is 24 minus x. The lengths of two sides of the triangle are represented by the equations 5x minus 7 and 2x plus 5. Okay, so here's a triangle. I don't know what kind of triangle it is. And they said the perimeter is equal to 24 x minus 6. So the perimeter is all sides added together, right? On side 1, 2, and 3. If we add all 3 up, that's our perimeter, right? They told us 2 of the sides are represented by these expressions. So we've got one of the sides, I don't know which side, doesn't matter, 5x minus 7. And one other side would be like 2x plus 5. Okay, we don't know that one necessarily. Or not yet. Which of the following expressions represents the length of the third side of the triangle? That's what we're trying to find out. So this is like a polynomial kind of question, right? Remember when we added and subtracted polynomials. So if I say let's just think about this for a second. A perimeter of a triangle would be like the length of side 1 plus the length of side 2 plus the length of side 3. Actually, maybe I'll just use an L for length, okay? So the perimeter of my triangle would be length 1 plus length 2 plus length 3. Okay, so we know my perimeter is 24x minus 6, and that's equal to all these lengths added up. Well, we know two of the lengths, okay? So we know one of them, 5x minus 7, okay? Plus, next one, 2x plus 5. And I gotta move my triangle here now. Redraw that in a second. Okay, unknown. What did I say? Something like that. And this one is 2x plus 5. Okay, plus something. Okay, we don't know that side length. So I'm just going to leave that as my question mark. Now, if I can take this side and I'm going to try to get everything over to this side. So I'm basically going to take this perimeter and I'm going to subtract this length, and then I'm going to subtract that length to solve that. So maybe what would be helpful is to sort of show you this first. Think about it like this. I have my perimeter. I know length 1. I know length 2. I do not know length 3. So in order to get this unknown length, I'm going to have to subtract L1 from the left side. So I know a lot of times when we're solving equations, we'll do it very slowly, step by step. And might say if I have something like this, 2x equals 5x plus 1, and I want to get my x's to the left side. I'm going to subtract 5x. I'm going to write subtract 5x, and then cancel those out, and then write that's 3x, and then that's 1, right? But I know what I'm doing here. If I want to get rid of something on the side, if I'm getting rid of like this is plus, I'm going to subtract it, and it ends up on this side as subtraction, and it just kind of disappears from here. So now that we're getting more comfortable with solving equations, you probably want to try doing something like this. It's kind of like sort of shortcut steps, right? So I just had this 2x equals 5x plus 1. So I'm just going to kind of think in my head, I move this to this side, and if this was a positive, I'm going to subtract it. So now it's going to end up over here as 2x minus 5x equals 1. So without necessarily having to write below this minus 5x, cancel this, then we minus 5x here. I'm kind of like skipping this part, and I'm just moving it over. Okay, why am I showing you this? Because I want you to understand that when I take this length here, whatever it is, and I want to get it to my left side, I'm just subtracting it, right? I have the perimeter here is the total of everything. And in order to get what's left, I would subtract these sides, right? So I'm going to subtract length 1. I'm also going to subtract length 2. And that's going to be equal to the missing side, right? Also, maybe if I look at numbers, that would be easier. If I said my perimeter of this triangle is equal to 18, and this side is 10, and this side is 4, it's pretty easy for us to go, oh yeah, this missing side, well, that's equal to 4. So because I know 10 plus 4, I'm missing 4. But really what we did was subtraction, right? I said I've got 18 here. Well, I need to subtract 10 and subtract 4. That's subtracting 14, and what's left? 4. So we get our answer that way, right? Okay, so this is what I'm after. I have my perimeter. I have two side lengths. If I subtract each side length, I'm going to get the missing side. Okay, makes sense. All right, so taking us back up here. Let's see. Okay, so taking us back up here, I've got 24x minus 6 on the left side. That's that total. I'm going to subtract this whole length. Now, this is where we have to be careful. Let's keep these parentheses here. Okay, I put them in because I know that that's the length of this whole side. So if I'm going to subtract the length of this side, I have to subtract the whole thing, which means I'm going to put my subtraction sign in front of this whole thing, not just in front of the 5x, not just in front of the 7. I'm going to subtract the whole thing. So that's why I need to keep these brackets, because this is saying I'm subtracting everything here inside. Okay. All right. And then I'm also going to take this one, 2x minus 5, and subtract the whole thing. And that is going to equal my missing side length. Okay, so maybe I'm going to move over to the left here and see if I can maybe I can write smaller. I'll squeeze this in here. So I've got 24x minus 6, just copying over from here, right? Taking this and going over here. Now I'm going to, because I'm subtracting this whole thing, I have to apply this sign to both sides. Think of it like distributive property, okay? If I'm subtracting 5x, then I get minus 5x, but I have to subtract each part, both the 5x and the negative 7. So if I'm subtracting a negative, right? If we subtract a negative, that's like adding the opposite. We add a positive. So if I subtract negative 7, means I add 7. Okay, because I have to get rid of these brackets eventually so that I can collect like terms. Okay, so next here, same thing. I'm subtracting this whole thing. That means I have to subtract each part. Does that make sense? Okay, so I'm subtracting 2x. So I'm going to get minus 2x. And I'm going to subtract positive 5. So I'm just actually subtracting 5, right? In the first one, we subtracted a negative. So we ended up adding that 7. But here, this was already positive. So if I'm subtracting it, it just becomes subtraction. Okay, so now I can collect all my like terms. I've got 24x minus 5x minus 2x. So 24 minus 5 is 19. And then 19 minus 2 is 17. So I should have 17x. And then I've got negative 6 plus 7 and minus 5. So I've got negative 6 plus 7 is positive 1. Positive 1 minus 5 would be negative 4. So if I did this right, I should find my answer here somewhere. And I do. 17x minus 4. There it is. Answer is D. All right, so that was kind of a long-winded explanation. But if I don't take my time to explain it that way, we could end up, first of all, not knowing where to start, and second of all, making mistakes like not you not subtracting correctly for the whole thing. Okay. So yeah, so if you get a question like this, maybe when you draw your little diagram to help you out, start by putting parentheses on it. Realize we're going to say this is one whole length. So if I need to subtract that from the total of my perimeter, I'm going to, right, be subtracting that whole thing as we did above here, right? Here and here and there. Okay, carrying on. Again, feel free to ask me questions about any of this in class or hit me up on Teams. Where are we at? 29 minutes. All right, we're just cooking through this, aren't we? All right, now again, I'm taking a lot of time to go through these to really explain them. But when you do a question, if you come across a question like this, and you've practiced it and you've practiced it again and you've practiced it again, and it makes perfect sense to you, you understand the process, you understand how you would do this, you're going to be able to go a lot quicker, right? Once you're very confident with that. So hopefully we are doing a lot of practicing, and I hope that this will help you. All right, so I'm going to erase this because you have the video now, which you can refer to. Scroll forward through time, scroll back through time. Imagine that you're capturing my voice, piece of time. You have like a little time machine now. You can rewind what I said. All right, get back to. Okay, number 7. Ross conducts a survey to determine the demand for a skateboard park. So, meaning how popular that skateboard park is. Ross can best minimize the bias in his survey by surveying people who fit one of these following 4 things. So, to have less bias, remember, what is bias? We said bias is like when uh, somebody's going to favor something. So, an example I told you guys in class was if I had $100 and I asked, and I wanted to know what sports equipment I should buy for the school to use, for everybody to use, and I surveyed only the soccer team, that would be a biased survey because, of course, they're going to want soccer balls. That's a soccer ball, not a chocolate chip cookie. Okay, so they're going to want soccer balls. So that would be biased because I'm focusing in on a particular group of people that are going to uh, skew my results, right? That will not be fair towards what I'm trying to understand. I'm trying to understand what is the best purchase for the whole school. Okay, so this person, Ross, is trying to determine the demand for a skateboard park, just in general. He's not saying from a particular group. He just wants to know what is the demand for his group. So if he asks at one location only, um, will he uh, minimize the bias? Will that reduce the amount of bad information, if you want to call it that? If he asks only people who have skateboards, if he only asks people who have skateboards, it will seem like everybody wants to go to the skateboard park because it doesn't say, this is not necessarily a survey specific to skateboarders, although kind of would make sense to survey skateboarders. But if you just maybe looking for demand in, um, the neighborhood or in the city as a whole, this could create a bias. And maybe if he asks people at the same time of day, um, that could potentially have some amount of bias because he is asking kind of still, it's sort of like a particular group, right? A sort of particular group that you would encounter at that time of day. Um, this is the skateboards are a particular group of people, or one location. That's just one particular area. But here, this just says people who are different ages. They don't necessarily have to be skateboarders. They maybe are asked these questions at different times of the day. Maybe at a shopping mall. Okay, maybe his skateboard park is attached to a shopping mall. And if he asks people only at 4 p.m., maybe he's going to find, just uh, kids who are just come out of school, and he's not really getting the best result. So asking at the same time of day isn't necessarily the best idea. Asking only people have skateboards, it's going to seem like his park is very, very in demand if he focuses only on them. And if he only asks people, I don't know, at the food court, maybe that's also not a good idea. So by asking people who are different ages, we're not specifying anything else. Those different people of different ages might be at different times of the day. Maybe he went to all different parts of the mall to interview people. Maybe he went outside the mall, right? So he went all over the place. He talked to all kinds of people at all times of the day. So there's less chance of there being bias there if he just focuses on people with different ages. Um, okay, that's the would have best way to have the least amount of bias. So answer here should be C. Okay, so the square PQRS has been dilated to form the square P prime, Q prime, R prime, S prime, as shown on the grid below. So here it is. We've got our uh, main square here, and here it's smaller. I like to consider this more like, we can call this like a reduction, right? We said there was enlargements and reductions, but it's been dilated to form this square. So it's Now smaller. What is our question? What is the scale factor of the dilation shown above? So basically, what is our scale factor in going from this one, because we started with the square PQRS, and then it said it's dilated to form this one. So think about it this way. We're starting with this one and we're going to this one. So what would be my scale factor? Did it get bigger? No, well, it got smaller. So remember, if something gets smaller, my scale factor should always be something less than 1. So something like 1 over something, right? If my scale factor is something like 6, that means the object getting bigger. Okay, so in this case, we're going from here to here, from Q to Q prime, or PQRS to PQRS prime. We should have a fraction for our scale factor. So now the question becomes, how much bigger are these? What's the difference in these sides? Well, now this thing cuts through these squares on diagonals, but we can still, if you look closely, again, if you're looking at this on the screen, you can zoom your screen in just like I can and get a closer look. So I can look at the side length. It's one of these diagonal lengths, right, in this square. And here's another diagonal length. So I can compare these because I still have something that I can measure by. I've got two of these diagonal lengths. So I could kind of say this is length 2. And then how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 of those here. So it looks like from 2 to 10, we multiplied by what to get from 2 to 10 times 5, right? Or if we went this way, we divided by 5 to get to the smaller number of 2. So my scale factor should be 1 over 5, right? That's like we're dividing by 5, right? So it's 1 over 5. I use the scale factor if I were to multiply the length of this side 10. 10 times 1/5 would give me 2, right? So that's going to be my scale factor here. And I think I'm going to stop this video here. Okay, we'll carry on in a minute.